Hi everyone, I'm Cheryl. In this problem, we're asked to evaluate a vector-valued function for several values of t. Our vector-valued function is the function 1/2 t squared times I minus the quantity t minus 1 times my vector j. And in the first example, I'm asked to find r of 1. So every time I see a t in my vector-valued function, I'm going to replace it with a 1. So I have 1/2 times 1 squared times I minus the quantity 1 minus 1 times j. This leads to 1/2 times my vector I minus 0j, which I can just write as 1/2 times vector I. Okay, let's try another example. This time I'm looking for r of 0. Again, every time I see a t in my vector-valued function, I'm going to substitute in 0. So I have 1/2 times 0 squared times vector I minus the quantity 0 minus 1 times vector j. This is going to give me 0i plus j, which will simplify to simply my vector j. All right, so the next one's a little bit more complicated. Instead of substituting in a numeric value for t, we're going to be substituting in an expression. So every time I see the value t in my vector-valued function, I'm going to replace it with an s plus 1. So this gives me 1/2 times the quantity s plus 1 squared times vector I minus s plus 1 minus 1 times my vector j, which is 1/2 times s squared plus 2s plus 1 times vector I minus s times vector j. And you can even distribute that 1/2 across so that you have 1/2 s squared plus s plus 1/2 times vector I minus s times vector j. All right, the next one is even a little bit more complicated because we are subtracting my vector-valued functions. So for the first term, I'm going to be taking r of 2 plus delta t, and then I'm going to subtract r of 2. So we'll begin by evaluating r of 2 plus delta t. So every time I see a t in my vector-valued function, I'm going to replace it with a 2 plus delta t. So that's going to give me 1/2 times the quantity 2 plus delta t squared times vector I minus 2 plus delta t minus 1 times my vector j. Then I'm going to subtract r of 2. Every time I see a t in my original vector-valued function, I'm going to replace it with a 2. So that's going to be 1/2 times 2 squared times vector I minus 2 minus 1 times vector j. Okay, now I have some simplifying to do. I'll have 1/2 using FOIL on this piece times the quantity 4 plus 4 delta t plus delta t squared times vector I minus, this piece reduces to 1 plus delta t times vector j. Then I'm going to subtract 1/2 times 4, so that'll be 2 times I, and 2 minus 1 is 1, so that'll be minus my vector j. Okay. I can go ahead and distribute that 1/2 across, and I'll have 2 plus 2 delta t plus 1/2 delta t squared, all of that times my vector I. And then I'll subtract 1 plus delta t times vector j. I'm going to go ahead and distribute that minus across and look at this as a minus 2 times vector I plus vector j. And now I can combine my components. My I components can be combined together and my j components. So I'm going to have 2 plus 2 delta t plus 1/2 delta t squared minus 2 times my vector I. And then I'm going to add to that a minus the quantity 1 plus delta t plus j, or plus 1, all right, times my vector j. Okay. This then reduces to a 2 delta t plus 1/2 delta t squared times my vector I, because the 2's add together to be 0. And then in my next piece, I notice I'll have a minus 1 minus delta t plus 1 times my vector j. And one more simplification step, 2 delta t plus 1/2 delta t squared times vector I, and this becomes a minus delta t times my vector j. And I have everything simplified. I hope that was helpful. Thanks.